All right, we are looking at section 4.4, trig functions of any angle. I am here live with a majority of my Block 2 class. You guys want to say hey? Hi. Awesome. Okay, they're super excited that we're recording today. Section 4.4 is called trig functions of any angle. Our definition of a trig function of any angle: let theta be an angle in standard position with x comma y a point on the terminal side of angle theta, and r is defined as the square root of x squared plus y squared. So in this section, we are looking at finding the trig functions of angles where the ordered pair might not be on the unit circle. So we're stepping off of the unit circle now, and the point could be anywhere in an xy plane, for example. So this ordered pair, xy, happens to be in quadrant 2. Doesn't have to be, but this one is in quadrant 2. And here's our angle theta, okay? And the r is going to represent the distance that that point is from the origin. So that's your length r right there, the distance that that point is from the origin. So how would we find that length? Well, if we're going to find that length, we could use Pythagorean theorem, right, that you already know. This is our x, this is our y, and so x squared plus y squared has to equal r squared. And if we solve for r, we're taking the square root of both sides, and that's how we get this formula for r. Okay? Okay? So that means when we draw these angles, there's going to be an x, a y, and an r, and we need all three of those to help us get the 6 trig functions. All right, so the 6 trig functions are defined in this section. The sign is, you know, the sign is y, right? But that's only if the radius of a unit circle is 1. Now we're off of the unit circle, so we need to say that the sign is y divided by r. If r was 1, then it would just be the sine of theta is y. All right, the cosine is going to not just be x, though. Now it's going to be x over r. And the tangent is still the same. The tangent is still y over x. These other 3 trig functions, as you know, are the reciprocals of those. So secant is going to be what? And yes, I'm getting my popsicle sticks out. Allie? Secant, is that the reciprocal of, is it the reciprocal? Is it the reciprocal sine? Or secant the reciprocal cosine? It's the reciprocal of what? Cosine. So it's got to be what? All right, so the secant of theta is going to be r over x. How about the cotangent? That's going to be equal to what, Grace J? R over y. R over y. And how about the cosecant? That's going to be what, Rachel?
Isn't cotangent the reciprocal of tangent?
Yeah, so we got that. Oh, did I write that wrong?
Yes.
No, I said it wrong. It's x over y.
It's x over y. So cotangent is x over y. And so the cosecant is going to be what?
R over y.
R over y, because that's the reciprocal of the sine. So let's remind ourselves of what our reciprocals here. Sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals. Everybody agree? Okay? All right. So those are our definitions that we're going to be working with. And it's interesting and important to point out that r is never going to equal 0. And r is always going to be positive, okay, because we're taking the square root of x squared plus y squared, so it's never going to be negative, it's never going to be 0. So sine and cosine are defined for all angles theta, but if x equals 0, then what trig functions will be undefined? So you're looking at those formulas that we just wrote down. Which trig functions are going to be undefined if x is equal to 0? What do you think there, Garrett? Which of these trig functions is going to be undefined if x is equal to 0?
Cotangent and cosecant.
Cotangent and cosecant?
Yeah.
If we're dividing by x,
Yeah.
then x
Oh.
cannot equal 0. So which trig functions are we dividing by x? For which trig functions do we have to? All right, secant has an x in the denominator. Tangent has an x in the denominator. So for what trig functions will these be undefined? We will say secant and tangent. All right, which trig functions are going to be undefined if y is equal?
That's
All right, which one are those going to be, Garrett?
that's correct.
All right, which ones?
Cotangent and cosecant.
Cotangent and cosecant have y's in the denominator, so those are going to be undefined when y is equal to 0. Are we okay with this? All right. So let's take a look at this example. Let -2, 3 be a point on the terminal side of angle theta. I want you to find the sine, the cosine, and the tangent of angle theta. All right, so in this case, let's start off by drawing a picture of what's happening. We are going to plot -2, 3. So -2, 3 is right here. And that is on the terminal side of the angle. So from 0, 0, we need a line that's kind of going through -2, 3. And your initial side is always the positive part of the x-axis. So really, we're talking about this angle theta, but in your book, they talk about something called reference angles. And I really don't want to get into reference angles that much, but I do want to say that for us and our purposes, we're going to find the sine, cosine, and tangent by drawing a triangle. All right. So we plot that point, -2, 3, and then we always drop a vertical down to the y-axis. We're never going to draw a line over to the x-axis. It's always down to the y-axis, and therefore we're making a right triangle. Okay. The reference angle for theta is really going to be this angle right here. So that's going to be your angle theta. All right. So what we're really interested in, is this triangle right here. I'm going to kind of blow it up a little bit bigger here. So this is a right angle. This is our angle theta. This is -2, 3 over here. So this is -2. This is 3. Right here's 0, 0. That's -2. That's 3. We need to find r. That's this hypotenuse, right? And our formula for r is what? Dylan.
The x squared plus the y squared plus x squared.
X squared plus y squared, and then we take the square root
Right.
of that, right? So we need to find this length r, so it's going to be square root of -2 in parentheses squared plus 3 squared. So what does r turn out to be, Allison? So we get square root of 13. Okay, so what do we know? We know x is -2. We know y is 3. And we know r is square root of 13. Everybody agree? At this point, we're going to use those formulas that we just learned to find the sine of angle theta, the cosine of angle theta, and the tangent of angle theta. So a little help with that here. Um, Ryan,
Sine is 3 over square root of 13.
what's our formula for sine?
Is y over r.
Y over r. So that's going to be 3 over square root of 13. And of course, we're going to simplify this and multiply this by square root of 13 over square root of 13.
Yep.
Right?
So you have 3 times square root of 13 over 13.
3 square root of 13 over 13. Are we okay with this? All right. How about the cosine? What's that going to be, Hannah?
Cosine is x over r,
Okay.
so it's negative 2 over square root of 13.
Okay.
And then you have to rationalize it, so
Yep.
you get negative 2 square root of 13 over 13.
So negative 2 square root of 13 over 13.
Yeah.
Okay. And how about the tangent? Grace K?
The tangent is y over x, so it would be 3 over negative 2.
3 over negative 2. Are we okay with this? All right. All right, moving on. So cosine, let's remind ourselves, I know we talked about this before, but cosine will be positive whenever x is greater than 0. So in what quadrants will cosine be positive? In which quadrant or quadrants will cosine be positive? Rebecca? So you're saying cosine is going to be positive here and here, right? Okay. In what quadrants will sine be positive? Well, sine's going to be positive whenever the y is greater than 0. So in what quadrants is the sine positive? Grace J?
1 and 2.
1 and 2. So sine is positive here and here. Everybody agree? And the tangent is going to be positive whenever x and y have the same sign, S-I-G-N, right? Either x and y are both positive or x and y are both negative. So in which quadrant or quadrants will the tangent be positive, Garrett?
So you want to go, it'll be 1 and 3.
Yeah, so 1 and 3. So tangent is positive in 1 because both x and y are positive, and tangent is positive in 3, right? Because both x and y are negative. So if I take a negative divided by a negative, I will get positive. All right? So the way that I think maybe I talked to you about this before, maybe not, for quadrants 1, 2, 3, and 4, you can remember which ones are positive. We say all the trig functions are positive in quadrant 1, sine is positive in quadrant 2, tangent's positive in quadrant 3, and cosine is positive in quadrant 4. And so you can remember all students take calculus. It's just a mnemonic device for remembering what's positive. And don't forget, not only is sine positive, but the reciprocal of sine is going to be positive as well, right? That's cosecant. And not only tangent's positive down here, but its reciprocal, cotangent. Cosine is positive and its reciprocal in quadrant 4, so that's secant and so on. All right, so we talked about what's positive where. So in this, I mean, they show this in the book. You don't have to copy this down. But here, sine is positive, cosine is positive, tangent's positive. Here, sine is positive, but cosine and tangent are negative. Here, tangent's positive, but these guys are negative. And here, cosine is positive, but these two are negative, right? Pardon me? What page in the book is that? Is it 313? Yes, it is. Off to the side there. Are we okay with this? Rachel?
Did you go back to the where it said like tangent will be positive whenever?
If tangent's going to be positive, remember the formula for tangent is, tangent of angle theta is going to be y over x. x. So if y and x are both positive, then y over x is going to be positive. If they're both negative, a negative divided by a negative is also positive. So you have to be in a quadrant where your order pairs are both the same. So here, this order pair is positive, positive, and in quadrant 3, it's negative, negative. Here it's negative, positive, here it's positive. All right. All right. So let's take a look at this problem. Given information is that the sine of theta is equal to 4/5 and the tangent is less than 0. Find cosine and cosecant. Find cosine of theta and the cosecant of theta. I think right now, after all this discussion about what quadrants things are going to be positive in, can we figure out what quadrant theta is in this problem? Theta must be in quadrant what? What do you notice? What are our clues? Our clue is that the sine of theta is 4/5. So that means sine of theta is positive, right? It's greater than 0. And we know that the tangent of theta is less than 0. So which quadrant has sine positive but tangent negative? Garrett?
Well, so that would be the second one.
Second quadrant. Do people agree? Yeah, sine is positive, tangent's negative. So that means we want to draw a sketch in the second quadrant, right? So I'm just going to put a point somewhere in the second quadrant, and I'm going to draw a segment from 0, 0 out to that point. And remember, what's our rule? We're going to make a triangle, but we're never going to go to the x-axis. We're always going to go to the y-axis, right? And make our triangle. Here's our angle theta, right? The angle theta has always got to be over here. We never want to put angle theta up here, right? Certainly not going to be the right angle. That's no good. It's always the one right by the origin, okay? And what do we know? If we know that the sine of theta is 4/5, what's our formula for sine?
It's y over r.
Y over r. So we can use 4 as our y and 5 as our r. Everybody with me? I know that this is my x, this is my y, this is my r. Correct? So I can fill in that the r is equal to 5 and the y is equal to 4. Everybody agree? Rachel? So we just need to find the x, correct? So you can use Pythagorean theorem, right? X squared plus y squared equals r squared. And we can say x squared plus 4 squared equals 5 squared, right? So we get x squared plus 16 equals 25. And what's x squared turn out to be? X squared is 9. So x is going to be 3. So it's going, remember, we take the square root. But what do we have to remember when we take the square root? Plus or minus. So I need plus or minus 3. Do I want x to be positive 3 or negative 3? Look at the sketch. Negative. Right? Because I'm going to the left. And not only that, we've already decided we're in quadrant. Oh, I didn't even write it down. Quadrant 2. In quadrant 2, ordered pairs are always negative, comma, positive, right? So my cosine has got to be negative. So that means we want negative 3 for our x. X has got to be negative 3. Okay? Now we know that x is equal to negative 3, y is equal to 4, and r is equal to 5. Correct? Now we're in business. Now we can find whatever trig function they're asking us to find. And they are specifically asking us to find what? Cosine and cosecant, right? So what is the cosine of this angle theta, and what is the cosecant of theta? Can you give me cosine here, Dylan?
Negative 3/5.
Because the formula is
X over R.
x over r, so this is going to be negative 3/5. Are we okay with that? And the cosecant is going to be what, Allison? Because the formula is r over y, so that's going to be, you said 5/4? Are we okay with this, Rachel?
How did you know that it was in quadrant 2?
We were detectives, we used some clues. They told us that the sine of theta was 4/5, which means that the sine is positive, and we were told that the tangent of theta was negative. So then we said, in which trig function is sine positive but tangent negative? And that would be right here in this quadrant 2. Sine is positive, tangent's negative. Are we okay with this? All right. Okay, so now let's talk about trig functions of quadrant angles. Quadrant angles are just going to be angles that end up on one of our axes. Okay, so they either end up right on the y-axis, like pi/2 or 3pi/2, or they end up on our x-axis, like pi or 2pi or 3pi or 4pi. Okay, so can you evaluate cosecant of theta and cotangent of theta for theta equals 0, pi/2pi, and 3pi/2? All right, got that out. So if we have a 0-degree angle, give me one ordered pair that's on a 0-degree, on the terminal side of a 0-degree angle. Give me one ordered pair that's ordered. What's that? Sure, we could use 1, 0, we could use 2, 0, we could use 5, 0, doesn't matter. If we use 1, 0, then we want to find the cosecant of 0 radians, and we want to find the cotangent of 0 radians. And remember, our formulas are still cosecant is equal to, what is it? R over y, is that correct? And cotangent is equal to, is that
X over y.
x over y? So if our ordered pair here is 1, 0, that means that x is 1, y is 0, and what's the r going to be? 1, because remember, r is the square root of x squared plus y squared, so that's square root of 1 squared plus 0 squared, that's the square root of 1, which is 1. So r is equal to 1 also, right? And so in this case, we would get r over y is going to be equal to what here, Ryan?
R over Y, so it's 1 over 0.
And what's that equal to? That is undefined. And if you just leave it 1 over 0 on a quiz or test, I will have to mark that wrong, because you're not telling me that you know that that's undefined. Okay, what about cotangent of 0 for x over y? That's going to be equal to what, Rachel?
1 over 0, which is undefined.
1 over 0, which is also undefined. So these two trig functions, cosecant and cotangent, are both undefined at 0 radians, right? Does that make sense? Okay, let's just do one more of these. We're not going to do all of them. How about pi over 2? So now, if we want an angle here where the terminal side is right here, pi over 2, give me an ordered pair that's on this terminal side here. Rebecca. All right, let's do 0, 2. So for that problem, here, the x is 0, the y is 2, and what's the r going to be? Garrett? Would it be 2? Square root of 0 squared plus 2 squared, that's square root of 4, which is 2, right? And so if that is the case, this is what we're using, and now we want to find cosecant of cosecant of pi over 2 and cotangent of pi over 2. Again, we need, cosecant formula is r over y, is that correct?
Yep.
Cotangent is x over y. So can you help me out here with these, Grace K?
For cosecant, it would be 1 because the y is 2.
Oh, okay, so it's going to be 2 over 2, which is equal to 1. Do people agree with that? And how about the cotangent?
It would be 0 over 2, which is 0.
Which is 0. Are we okay with that? All right, so you get the idea on how to find the trig functions of these quadrant angles. Okay? All right, moving on. So now, can we evaluate the sine, cosine, and tangent of the angle without using a calculator? So if we want to find the sine of negative 750 degrees without using a calculator, what do you think we can do? Garrett?
Well, we use, so we could do like what we do on those radians in a unit circle, you subtract 260 from
Okay, so instead of subtracting 2 pi like we would if it was in radian measures, we could subtract 360 or multiples of 360?
for this actually. Add
Add 360? Okay, so let's do that. So what is negative 750 plus 360?
390,
Negative 390. Is that one that we know, like on our unit circle?
So
No.
you could
Add another 360? What does that get us? Negative 30? Is that one that we could maybe reason out on our unit circle? Sure. So on our unit circle, we know that negative 30 would be down here, negative 30 degrees, and that ordered pair is what?
Square root of 3 over 2, negative 1.
Square root of 3 over 2 comma negative 1/2. So our sine value then is going to be what?
Negative 1/2.
Negative 1/2. All right, if we want to find the cosine of negative 750 degrees, that would be what? Rebecca?
Square root of 3.
Square root of 3 over 2. And if we want to find the tangent of negative 750 degrees, that would be the same as the tangent of negative 30 degrees. So we would do what to get that? Hannah? What's that formula for tangent?
X over y.
Careful on that.
Y over x.
Y over x for tangent.
1/2, or negative 1/2 square root of 3 over square root of 2.
Okay, so we want negative 1/2 over square root of 3 over 2. So that's negative 1/2 times the reciprocal. The 2's are dividing out. We get negative 1 over square root of 3, right? Multiplied by the rad 3 over rad 3 to get our simplified answer of,
Negative 1 square root of 3.
all right, negative square root of 3 over 3. Are we okay with this? All right, let's take a look at another example. Find the indicated trig value in the specified quadrant. All right, all we know is that sine of theta is negative 3/5, and that we want to be in quadrant, that theta is in quadrant 4, and the trig value we're trying to find is cosine. Find the indicated trig value in the specified quadrant with the clue that the sine of theta is negative 3/5. Garrett?
use a unit circle.
We could use the unit circle, but I think in this case we do want to draw a sketch, but maybe not the unit circle. Let's do this. We want to draw quadrant 4, so I got quadrant 4 here, and we want to draw this point somewhere in quadrant 4. We're going to go from the origin out to that point, wherever it is, and we're making a triangle. Do we go to the y-axis or up to the x-axis? We always want to draw a line up to the x-axis, right? And so we're making this angle And technically, this is gonna be like our reference angle for what the real angle, I mean, the real angle is this, right?
Because it's supposed to be in front.
Yeah,
You're right. Yeah.
Oh, did I draw in quadrant 3?
yeah.
You did.
Rewind. Thank you. Good thing I have you guys to keep me honest here. All right, so we want to be in quadrant 4. No wonder you guys are all confused. Sorry, my bad. So we want to be in quadrant 4, right? So the real angle is looking like this, right?
Yeah.
But we don't want to draw it like that. It's much easier to get the reference angle, which would be, we go to the x-axis to make our right triangle, and it's this angle right here that's going to be our reference angle for this problem. So we're going to call that angle theta. We know that the sine is -3/5, and the formula is y over r. So can you fill in this triangle, what side is going to be -3, what side is going to be 5? Garrett?
So -3 is gonna be no, it's gonna be the far right.
All right, so here,
Yeah,
so this is your y, so that's -3.
and then 5 is gonna be hypotenuse.
Hypotenuse here is 5. That's our that's r. Are we okay with this?
So, how do we know that 5 is not negative and that it's?
That's an excellent question. The question was, how do we know that the r was not negative? Okay, because the r is always the square root of x squared plus y squared, and when we take the square root of something squared and something squared, it's always going to be positive. So r is always,
So whenever there's a negative, it's always gonna be like the y or the x.
right. So if it's tangent or cotangent, well, then you got a problem because it's y over x. But if it's something with an r in it and there's a negative, it goes with the other part, the x or the y.
For tangent and cotangent, how do you know when x is negative or y is negative?
Then you would have to decide based on the quadrant. So like if I say tangent's negative, but we're in quadrant 2, then the x is negative and the y is positive, right? But if you're in quadrant 4 and the tangent's negative, then the x is positive and the y is negative. Does that make sense? Okay, so we know that the y is -3 and the r is 5, and we could find x here by using this formula right here. So we're going to say, well, r squared equals x squared plus y squared. We're going to get 5 squared equaling x squared plus -3 squared. So we're getting 25 equaling x squared plus 9. Did you get x squared equaling 16? When you take the square root, you need to remember plus or minus. So it's plus or minus 4. We're in quadrant 4, so is x positive or negative? Positive. So x should be a positive 4. Now that we know that x is 4 and y is -3 and r is 5, we could find any trig function, right, using those, but they're only asking us to find cosine of theta, so that's going to be what? That'll turn out to be Hannah.
It would be 4/5 because the formula is x over r.
X over r, so that's 4/5. Are we okay with this? All right. Moving on. Okay. For this example, let theta be an angle in quadrant 3 such that sine of theta is -5/13. Use trig identities to find secant of theta and the tangent of theta. So this time we're not going to draw a picture of a triangle in quadrant 3. We're going to use trig identities. All right? Remember I said you don't have to memorize these yet, right?
Which ones do we have to memorize, like, of those equations?
For the basic trig identities, you're going to have to memorize them all in January. But, especially for our work in chapter 5. okay? But for right now, let me remind you what page these are on. Anybody find it?
I haven't written down.
You got them written down in your notes, that's good. I think they were in section 4.3. Is that accurate? Yep, they are on page 304. So take a look at page 304 in your book. In this problem, they're giving you the sine of theta, and they're asking you to find, first of all, the secant of theta. Well, we might need to find cosine first, because I don't know if there's one identity that just has sine and secant in it. But we could find cosine first. What's the identity on page 304 that involves sine and cosine, and only sine and cosine? No other trig function. Rachel?
Sine squared theta plus cosine squared theta equals 1.
All right, so we want to use sine squared theta plus cosine squared theta equals 1. We're going to try and find cosine first, so we're going to plug in -5/13 for sine, and we have to square it, and then we want to say plus cosine squared equals 1. What's -5/13 squared? Is that going to be 25 over, is that 169? You're checking me? Plus cosine squared theta equals 1. We need to subtract 25 over 169.
It's negative.
What's wrong?
4 on that one.
Oh yeah, because -5 is being squared, so it's going to be positive 25, correct?
Yeah.
But I'm subtracting that from both sides, so I end up getting cosine squared theta equaling, I mean, 1 is really, I could write this as 169 over 169, right? Minus 25 over 169. What does that leave me with? 144 over 169. Does this look okay? Why are we finding cosine? Because we don't have any identity on page 304 that only involves sine and secant. So I guess I would say hint on this one. Hint, find cosine theta. That's what we're doing. Then secant is going to be the reciprocal of cosine, so we'll get our answer. Okay, so now what do we have to do? What's our next step? In finding cosine, we need to do what? Take the square root. So we're going to take the square root of both sides. What do we need to remember when we take the square root?
Plus or minus.
Plus or minus. And so we get cosine of theta equaling plus or minus, what's the square root of 144 over 169?
12 over 13.
12 over 13. Now, can we decide right now, is cosine supposed to be positive or negative? Did they give us a clue as to what quadrant we're in?
3.
They told us quadrant 3, so is cosine positive or negative in quadrant 3?
Negative.
Negative. All right, so that means that the cosine of theta is most definitely negative 12/13. So I don't need to use the plus or minus anymore. I want it to be negative. All right, and so now what other identity, and I like to put these identities in boxes, have them stand out. What identity would I use to get from cosine to secant?
Cosine theta equals 1 over secant theta.
Or the reverse of that, which would be secant of theta.
Equals cosine.
Secant of theta equals,
Equal.
you told me cosine equals 1 over secant, or secant equals
Cosine.
1 over cosine, right? Agreed? Cosine's equal to 1 over secant, so secant's equal to 1 over
yeah,
cosine.
yeah.
And I'll put that in a box to say, hey, this is the identity I'm using. And then, let's write this down at all, yes I can. And so I get secant of theta is equal to 1 over, what was it, negative 12/13?
Yes.
So that's going to be negative 13/12. Are we okay with it? All right. Then, how could we find tangent of theta? Which trig identity on page 304 could we use to find tangent? Garrett?
Well, since we already have, we use 1 plus tan squared, no wait. We're probably not looking at that. No, yeah. I'm thinking you could use 1 plus tangent squared theta equals secant squared theta. So
Sure, you could do that. You could use 1 plus tangent squared theta equals secant squared theta and solve for
13, 12.
tangent, right? Or what other one could we use? Allie?
We know sine A cosine
Tangent theta equals sine theta over cosine theta? So really, either one, because we already know secant and we already know sine and cosine. So it would be your choice, and will you get the same answer?
Yes.
Yes. All right. So you pick which one you're going to do. Which one of them? If we get the secant plus 13/12. You're trying one of these methods, right? I'm just trying this first one. And so I am getting that the tangent squared theta is equal to, is that 25 over 144? And I take the square root and plus or minus, and I get tangent of theta equals plus or minus 5/12. But I know I'm in quadrant 3. So tangent is positive or negative? Tangent of theta is greater than 0. So that means my answer should be positive 5/12.
I got negative.
It's
Two negatives. There was a negative in the second.
Did we get
Oh, there was.
Did we get the same answer either way?
Yes.
yeah.
Yeah, so if you tried this method here, you still got the same answer? Oh, awesome. All right, let's talk about this. Use your calculator to evaluate the following. How about cotangent of 375? So we reach for our calculator and going to a calculator page, and we wanted, what was it, cotangent of 375. So I go to trig, cotangent of 375. Now notice I'm in radian mode, as you are. We all made a pact, right?
Yes.
So we have to override this by pushing the question mark button and the degree symbol, and I am getting 3.73-ish. Are we okay with that? Okay, now, when you take a quiz or test for me, you're going to go into press to test on your calculator, and that means that all these guys here are blocked. You're not able to do cosecant, secant, or cotangent. So how would you answer this question of what's the cotangent of 375 if you can't use the cotangent button? Find what? Find tangent and then make it the reciprocal. Let's test that. So tangent of 375, push the degree symbol. That gives me 0.2679. And then if I want the reciprocal of that, I can do 1 divided by that answer. Do you guys know how to do that answer? Control negative?
No, how do you do it? Oh, so
Control the negative. And so I end up getting, there it is, 3.732, just like we got before. Are we okay with this? All right. And how about sine of negative 4.1? Is that radians or degrees? That's radians because there's no degree symbol. So if we want sine of negative 4.1, sine negative 4.1, I'm getting 0.818. Does that look okay? Okay. What else is to come? Oh, that. Oh, all right. One last example. Whew. One last example. This one says find two solutions of the equation. Give your answers in degrees and radians. Make that a capital. And do not use a calculator. All right, here's our equation. The cosecant of theta is equal to 2 times the square root of 3 over 3. And you can't use a calculator. And you got to find out what angles in radians and degrees would give us this. All right? I don't know about you, but I'm not all that familiar with cosecant, but I'm a lot more familiar with its reciprocal, which is what? Sine. So if the cosecant of theta is 2 rad 3 over 3, what's the sine of theta going to be? 3 over 2 times the square root of 3. Do you agree? And let's simplify that because maybe it'll be something that we recognize. Can we get rid of that radical in the denominator? Multiply by square root of 3 over square root of 3, and we get 3 square root of 3 over 2 times square root of 3 times square root of 3. Isn't that going to be 3? Yes. And so can I divide out these 3's?
No.
No, yeah, wait.
No.
Yes.
Why not? Why?
Yes.
They're not terms.
They're all terms. Everything's being multiplied. Neither one of these are under a radical, right? It's okay? So this is going to be equal to square root of 3 over 2. Does square root of 3 over 2 sound familiar?
That's one of the values in unit circle.
It sure is one of the values on the unit circle. So at this point, let's look at our unit circle. Where on our unit circle is the sine equal to square root of 3 over 2? Hands, please. Some help. You're looking at your unit circle. Rachel. Give me one place on the unit circle where the sine is equal to square root of 3 over 2.
2 pi over 3, and that's at
2 pi over 3. So 2 pi over 3 is right here, where the ordered pair is negative 1/2, comma, square root of 3 over 2.
yes, at 120 degrees.
Which is the same as 120 degrees. Okay, so we're supposed to get two solutions. So one solution could be theta is equal to 2 pi over 3, which is the same as theta equaling 120 degrees. Agreed?
Yeah.
Where else on our unit circle is the sine equal to square root of 3 over 2? Because there's somewhere else. Garrett? Pi over 6. Pi over 6 is right here. But the order pair there is,
Oh, yeah, no.
It's pi over
the sine there is 1/2.
So it'd be pi over 7.
You want pi over 3 instead?
Yeah.
So pi over 3 is right here. And again, that order pair is 1/2, comma, square root of 3 over 2. So I think we do like 2 pi over 3, and we like pi over 3 as another solution. And we like 120 degrees or 60 degrees, right, as our other. So we gave two solutions in degree mode and the same two in radian measure. Are we okay with this? All right, you guys are awesome. That's all the notes I have for you from this section. So I'm going to stop this video and tell you what your homework assignment is. Thanks for watching.